So on our notes, we're going to say, yep, we're continuing factoring. And this is going to be our 5th method of factoring. So I'm going to say factoring continued. Yet another day of factoring. And this is our 5th method of factoring. This is called sum or difference of cubes. What do the words sum or difference mean in math? Sum or difference, what do they mean? Add and subtract. So kind of like before we had difference of squares. Those were problems where you would have a binomial, so that means that it would have 2 terms. You would have a minus in between, and it would be 2 perfect squares. So you'd be looking for your square numbers like 1, 4, 9, 16, 25, 36, 49, 64. You'd be looking for those perfect squares. This time, we're going to have a binomial still. We could have a plus or a minus in the middle, and we're going to be looking for our perfect cubes. So the first thing I'm going to do is have us write down our perfect cubes, because those people don't have memorized as much, and we're going to need to recognize them. So 1 to the 3rd power is what? 1 times 1 times 1 is 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. 4 times 4 times 4. 4 times 4 times 4. You all have calculators in front of you. 4 times 4 times 4, 64. 5 to the 3rd, 5 times 5 times 5. 125. 6 to the 3rd is 6 times 6 times 6. 216. 7 to the 3rd, 343. Okay, and we're going to stop there because those are the most common ones that we're going to work with. We probably won't get much bigger than that. Okay, so there are 2 formulas, and we're going to write down what they are, but honestly, we're not going to use the formulas really. We're going to look at a pattern, and we're going to do the pattern with 2 different colored pens, and you guys are just going to follow the pattern, okay? So the formulas are, you could have 1 perfect cube plus another perfect cube. Or you could have 1 perfect cube minus another perfect cube. Okay? And here's what the formulas are. If you have 1 perfect cube plus another perfect cube, then the first factor is the number that was being cubed plus the other number that was being cubed. That's the first factor. Then it's the first number that was being cubed multiplied by itself minus the first number that was being cubed multiplied by the other number that was being cubed plus the second number that was being cubed multiplied by itself. So the formula feels kind of tricky, but you guys will see when we do the pattern, it's not as difficult, okay? Now let's do the second one. So this one is a number cubed minus a number cubed. So for this one, we're going to do the first number minus the second number. And then it's the first number multiplied by itself plus the first number times the second number plus the second number times itself. Okay, so those are the two formulas. Again, like I just said, we're going to use the colors and we're going to memorize a pattern kind of instead of memorizing the formula because it's easier. So the first thing that we're going to memorize is the acronym SOAP. The acronym SOAP helps us figure out what the signs should be. And what I mean by the signs is I mean the pluses and the minuses. So the first sign matches up with the sign of the original problem. So that means same. So if this is a plus, this is a plus. It's the same sign. The next sign is the opposite. If this is a minus, then it's going to be a plus. If this is a plus, then it's going to be a minus. The last sign you can see, no matter what, is always going to be positive. So we're going to write AP, AP. So that's where the acronym SOAP comes from. Same sign, opposite sign, always positive. Okay, so we're going to go ahead and we're going to try a problem. And we're going to use our colors so that we don't feel quite so confused. So we're going to try, first example, we're going to do x to the third minus 8. So the very first thing I'm going to do is I'm going to rewrite the problem as something to the third minus something to the third, because I want this to match the formula perfectly. So if I want to take the 8 out and rewrite it as something to the third, what would it be? It'd be 2 to the third. So this is going to be 8 to the third minus 2 to the third. Okay, now I'm going to switch to my colors. I'm going to use my first color for the x. I'm going to use my second color for the 2. Now, when we put this in the factored form, we have two sets of parentheses. We have a little set of parentheses, and we have a big set of parentheses. Okay? I'm going to figure out my signs by doing SOAP. So same sign, opposite sign, always positive. So if I follow this, what would the same sign be? Negative. Okay. What would the opposite sign be? Positive. And what would always positive be? Positive. Okay. All right, now I'm going to go ahead and do my colors. So the first thing I do is I do just the number and just the number. So I'm going to take the first one and I'm going to do just the number and just the number. Okay? Now the next one. I take the first number and I multiply it by itself. So I'm going to take x and multiply it by itself. X times x. Okay? Now for the middle one, I do the first number multiplied by the second number. So I'm going to do x multiplied by 2. And then for the last one, I do the second number multiplied by itself. 2 multiplied by 2. And what you notice is that when we followed the pattern, the first half of the parentheses was in one color, the second half of the parentheses was in the other color. Everyone see that? So what we can do is, instead of memorizing the formula, let's practice the pattern with the colors. Everyone see that? So we had one of each, and then we had 1, 2, 1, 2, 1, 2. Everyone see that? So one of each, and then 1, 2, 1, 2, 1, 2. Okay? And we did half of each color, half of each color. Can we all see the pattern? Okay. So at this point, all we have to do is just write down what we had, and then we'll have our final answer. So I have x minus 2 for the first parenthesis. And for the second parenthesis, I have x multiplied by x, which is what? X times x. X squared, okay? And then x multiplied by 2, x, and then 2 multiplied by 2, 4. Now, this part over here is a simple trinomial, and you would try to factor that if you could. So you would say, okay, what multiplies to 4 and adds to 2, right? You would do that problem, what multiplies to 4, adds to 2. And in almost every situation, that part does not factor. In fact, if you said, Miss Rice, give me an example of one that does factor, I could not come up with one for you because it very rarely does. Like, I can't think of one. Okay? So typically, once you've done this step, you are finished. That's the end of the problem. Okay. Let's try another one. We will do x to the third plus 27. So the first thing I need to do is rewrite it. So I have something to the third and something to the third. X to the third and 3 to the third. Okay, I'm going to write my colors in. Okay. I have little parentheses and big parentheses. And I'm going to write down soap. Okay. So same sign. Plus, opposite sign, minus, always positive, plus. Okay? So now we have to do the two colors, and we're going to do half and half. We do one of each. So I'm going to start with my first color, and then I'm going to do my second color. Now, when I look at my longer parenthesis, I get 2, 2, 2, and I have to split the colors in half. I have to do half of the colors in the first part, half the colors in the second part. And I get 2, 2, 2. Okay? So I'm going to take my first color, I'm going to do 2, and then I only get 1 in here, and then I have to switch colors. And then I get the second one, so I've got 2 of them, and then 2 of them. So we've got 2, 2, 2, half of my colors, half of my colors. Everyone see how I did that? See how I'm not even using the formula anymore? I'm just using my colors now. Okay? So I'm remembering the acronym SOAP, and I'm just being careful to use my colors. Half of the parenthesis, half of the parenthesis, half of the parenthesis, half of the parenthesis. How are you guys doing? Doing okay? Brain hurts a little bit? Okay. Okay. So the first parenthesis, we have x plus 3. And then what do we have here? X squared. And then what do we have next? Minus 3x. And then what do we have? Plus 9. Okay. Okay, we're going to make it more difficult. Are you guys ready? We're just going to make the numbers. We're going to make it so there's 2 numbers instead of 1 number. So I'm going to do 27 x to the third minus 125. Okay, so we have to rewrite it. So this time, the x is going to have a number with it. So what number do you guys think the x? Yeah, the x is going to have a 3 with it. So 3x to the third. Okay. What about the second part? 5 to the third. Okay. So let's take our colors and put our colors in there. So 3x is the first color. And then our second color is going to be 5. Okay. So we have a little set of parentheses and we have a big set of parentheses. And we have S-O-A-P. So what should I put for S? What would I put for S? If this is a minus, what do I put for S? Minus, okay, same sign. What do I put for O? Plus, okay. And then for AP, I put a positive. Okay. All right, what do we put in the first parentheses? Okay, we put the first color. And then what do we put? Second color. Okay. And then what do I do in this first space? Yep, take the first color, do it twice. Now I'm still on my first color because I haven't gone halfway through the parenthesis yet. So I need 3x. Now I got to switch colors because I've gone halfway. So switch to the other color. Now I'm on the second color, so I'm on the 5. So times 5. And now what do I do? Go to the next space, 5 times 5. Okay? And now what should I do? So we got 3x minus 5. Nine x squared. $15x. 25. Okay, let's try 64 plus 343x squared. Do we like it that they wrote it in that order? Yeah, we can take the number with the x, we can write that one first. So what should we write instead? Oh, sorry, I wrote squared, but I meant to the third. Hold on, this is a typo. There's a typo in the problem. There. Sorry about my typo. Okay, I fixed it. Okay, so I'm gonna rewrite it 343 x to the third plus 64. Okay, and then like Trevor was saying, this would be 7x to the third plus 4 to the third. Okay. Okay. So I'm going to put my first color in. Going to put my second color in. Okay. I got a little set of parentheses and a big set of parentheses and soap. So what do I put here? Plus. What do I put here? Minus, plus. Okay. So what should I write first? Okay. And what should I write here? 4. Okay. And then what should I write here? Okay. Okay. And then what about over here? Okay. How are we doing following the pattern? Good? Okay. So we have 7x plus 4. And then what do we have? (49x squared), perfect, minus 28x plus 16. Perfect. Ms. Rice, these are so fun. I know, right? No? Nobody? No? Okay, okay. All right, I want to show you, let's see. I want to make sure that you are fully ready for the assignment. Da-da-da. That puts some weirdness in there. It only does it once. Maybe I'll hand out the assignment. Let me hand out the assignment real fast, and I'll help you guys get ready for some of them. Okay. We have 2 practice sheets for this. Let me hand them out. They're different. All right, so if you look at this one first, this is not difference of cubes. Can anyone tell what this one is? It's difference of something. X squared and a 36. Uh-huh. Yeah. Uh-huh. 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 Do you remember what it's called?
No, I don't. That is not.
Yeah, this one has a special name. You want to take off the shades? Awesome. You can sit in that empty desk right there. All right, so anyone remember what these are called? This was on that little half sheet. You guys said you loved them. They were so easy. Difference of squares. Yeah, this one is a difference of squares. So these ones we liked because they were super simple. You just had two sets of parentheses, one with the plus, one with the minus. Remember doing those? And then you'd say, okay, 36 is a perfect square. So 6. The two numbers that multiply to 36 are 6 and 6. The two numbers that multiply, or the two variables that multiply to x squared are x and x. Okay. So on this assignment, you have difference of squares, difference of squares, difference of squares, difference of squares. And I can tell because it says x squared, x squared, x squared, x squared. Everyone see that? Okay, and then right here, this is where it switches over and it starts doing cubes. And I can tell because then it said x to the third. Everyone see that? Okay. So number 5, number 6, those look a lot like the ones that we just did. Number 7, number 8. Number 8 looks a little bit weird. How could we fix number 8? Yeah, so we'll do 64 x to the third plus 1. Okay, so that one looks a little bit better now. I'm going to do that one instead. Okay, 9 looks good. What about 10? 10 looks a little bit weird. Put the x in the front. So I'm going to write negative x to the third plus 1. And this one is actually very interesting because we haven't done one that had a negative in the front. And so what we do anytime this happens is we take out a GCF of a negative, which means we divide a negative out of each term. Okay? So if you have a negative here, we're going to take the negative out. And if you take a negative out of the x to the third, then you just get positive x to the third. If you take a negative out of the 1, you get a negative 1. So what you guys are going to end up with when you do this problem is you're going to have a little set of parentheses, you're going to have a big set of parentheses, and in front of all of it, you're going to have a very little negative sign. So now when you do the problem, you guys are going to ignore this negative, and you're going to do this problem. The same thing happens on number 12. See how there's a negative in front of the whole problem? So we would do the same thing. We're going to take the negative out. We're going to call that positive 27x to the third minus 125. And from there on, you guys are going to ignore the negative. You're only going to do this problem. But when you get to your final answer and you have your little set of parentheses and your big set of parentheses, at the very end of the problem, you're going to have a little negative in front of the whole answer. So you're going to ignore the negative. You pretend it's not there, but it's got to show up in your final answer. Okay? But the rest of the work, you can do the same as we did the other problems. Okay? All right, let's look at the other sheet. Actually, this one, I think this one's kind of cool because you'll have to get scissors out, and I will, I don't know if I have glue for everyone. We might just pass the tape around. But this one, you cut out the little pictures, and you put them where they belong, and you make a puzzle, like a literal puzzle, you know, like jigsaw puzzle, which I think is fun. It makes a little animal. Anyway, okay, then this one is a punchline. So number 4, you guys know how to fix now. Should we go ahead and fix number 7 together? since that's kind of a weird one? Okay, so what should I do first to fix number 7? So negative x to the third plus 27, okay? And then what else should I do? Take the negative out, x to the third minus 27. So when I do the problem, I'm going to pretend the negative's not even there. But in my final answer, I'm going to have a negative in front of the little set of parentheses. You guys see any more problems that are going to be weird? Number 8 is going to be weird. Okay, so what are we going to rewrite for that? Okay. And then what do we do? So take the negative out, put it in parentheses. Okay. And so now we know this is the problem we're working with. But our final answer, whenever we're done with the problem, is going to have a negative sitting in the front of it. Any other problems that are weird? Number 3? Number 3 is a little weird. How do we fix number 3? X to the third plus 8, just switch the order, okay? Anything else weird? I see one more weird one. And it's in the right order. Well, I see one that's out of order, and then I see one that's weird because the numbers are wrong. 11 isn't wrong, it's just we haven't done a 216 one yet. Number 4 is in the wrong order. Let's fix the order on number 4. So number 4 should be x to the third plus 27. Okay, and then Matthew, you mentioned 12. What's wrong with 12? 12 doesn't have a negative in front. 12 doesn't have a negative in front. But the numbers are wrong, right? So it's got a 24, not a 27. And then we didn't go high enough to see if 1029 is a good number or not. But we know 24 is not a good number, right? Okay, so what we're going to do is let's take our list of numbers. 27 was a good number, 24 was not. So what is probably happening is this one probably has a GCF. So if we look smaller than 27, is there a number on this list that divides into 24 and 1029? 8. 8 does. So 8 is probably the perfect cube sitting right here, which means that the number that multiplies by 8 to get 24 is probably the GCF. So we're not going to use it as a 24. We got to take the GCF out. So if 8 is the perfect cube that is probably there, then what is the GCF that's probably in the problem? 3 is probably in the problem. We probably need to take it out. So let's verify that 1029 divides by 3. We get 343. Is that a perfect cube? Yeah, so we have a GCF of 3 we got to take out, and then once we take it out, we're going to have our perfect cubes left over. So if we take out a GCF of 3, we are left with 343x to the third minus 8. And when you guys do this problem, you're going to do this right here, and you can ignore the 3 in the whole problem, but at the very end, you're going to have a 3 in front of your parentheses. See how that works? Okay, so what I'm going to say is I'm not going to make you do both sets of pages. I'm going to have you choose one or the other. And whichever page you don't do for regular credit, you are welcome to do for extra credit. So one page is regular credit, one page is extra credit, and I won't tell you which one you have to do. So choose one, regular credit. The second one is extra credit. and it's your choice. You can do it in pen. That's fine. Okay. All right, go ahead and get started.